All right, so the last two problems from the review assignment, 10D and 10E, I will go through right now the solutions. For D, we have a radical equation, so we want to get the square root by itself, which we have. We then need to square both sides to get rid of the square root. So square both sides. On the left-hand side, we're just left with what was under the square root. On the right-hand side, excuse me, there is a special formula, or you could use FOIL, or you could use the box method to multiply this out. So if we have x minus 1, using the box, I like to put the circle in the middle. X times x is x squared. X times minus 1 is minus x. Minus 1 times x is minus x. Minus 1 times minus 1 is plus 1. Our like terms, we have that minus 2x. So there is my x minus 1, the quantity squared. Because we have a term with x squared and a term with x, we're going to have to use one of our factoring methods, quadratic formula, something like that. To do that, we're going to subtract the 3x and subtract the 7 from both sides. Excuse me. And now, if we want to try to factor, we would check to see, are there two numbers that multiply to -6 and add to -5? And the answer is yes. -6 and +1. Setting each of those factors equal to 0, we get two possible solutions, x equals 6, x equals -1, and we should check both of those back in our original equation, which I will write down here. So if I plug 6 in for x, I would get 3 times 6 plus 7. Take the square root of that. Is that equal to 6 minus 1? 3 times 6 is 18, plus 7 is 25. 6 minus 1 is 5, so I get 5 equals 5. So 6 works. It is a good solution. For -1, I take the square root of 3 times -1 plus 7. Is that equal to -1 minus 1? So this would be -3 plus 7 is 4, square root of 4. -1 minus 1 is -2. And I already know that that can't be true because a square root can never be equal to a negative. So that doesn't work. You would actually get 2 equals -2, which is not true. So 6 is our only solution for part D. Taking a look at part E, there are two ways to go about this one. This is a quadratic type problem. So you could say, well, let's make a substitution. Let's let W equal x plus 3. You can use any variable you want, but the book, again, uses W. So then doing that, you would get W squared plus 5W equals -6. Bring the -6 over. W squared plus 5W plus 6 equals 0. Now check, do we know two numbers that multiply to 6 and add to 5? And in this case, we get 3 and 2. So W plus 3, W plus 2 equals 0. But W, as we said at the beginning of the problem, is x plus 3. So this would be x plus 3. That's going to replace the W. Then we have another plus 3. And x plus 3 plus 2. So x plus 6, x plus 5, 0. Plus 6. Subtract the 6. 5. So that's using that quadratic pattern and solving that way. There is a second way that you could solve this one. And the second way would be to actually multiply it out. X plus 3 squared. Square the first term plus 2 times the first term times the second. Square the last. Distribute the 5 through. Combine like terms and bring the 6 over. So we'd have x squared plus 11x plus 30 equals 0. Two numbers that multiply to 30 and add to 11 would be 6 and 5. And you'll see we're right back to where we were at the end, doing it with the substitution method. Set each factor equal to 0. And we get our two solutions.